Hi guys! So my topic is all about synthesizing images and propositions under the chapter 7, which is the landscape of memory, mental images, maps, and propositions. So in this chapter, we have discussed the two opposing views of knowledge representation. The first is dual code theory, that knowledge is represented both in images and in symbols. While the other one is the propositional theory, that knowledge is represented only in underlying propositions, not in the form of images, words, or other symbols. Next is Johnson-Laird mental model. A Johnson-Laird is well known as the human cognition and psychology of reasoning. According to him, mental model are knowledge structures that individuals construct to understand and explain their experiences. These models are constrained by the individual's implicit. When we say implicit, it is indirect or suggested theories about those experiences, which can be more or less accurate. Where is information manipulated? Left brain or right brain? Researchers found out that the right hemisphere appears to represent and manipulate visual spatial knowledge in a manner similar to perception. In contrast, the left hemisphere appears to be more proficient in representing and manipulating verbal and other symbols based on knowledge. And there are two kinds of images, visual and spatial. So visual imagery refers to the use of images that represent visual characteristics such as colors and shapes, while spatial imagery refers to images that represent spatial features such as depth, dimensions, distances, and orientations. So what is the difference between spatial cognition and cognitive maps? Spatial cognition, it deals with acquisition, organization, and use of knowledge about objects and actions in 2 and 3-dimensional space. While the cognitive maps are internal representations of our physical environment, particularly centering on spatial relationships. So cognitive maps seem to offer internal representations that stimulate particular spatial features of our external environment. And us, being human, seem to use 3 types of knowledge when forming and using cognitive maps. The first one is the landmark knowledge. It is the information about particular features at a location and which may be based on both imaginal and propositional representations. The second one is the road-to-road knowledge. It involves specific pathways for moving from one location to another, and it may be based on both procedural knowledge and declarative knowledge. And lastly, the survey knowledge. It involves estimated distances between landmarks, much as they might appear on survey maps, and it may be represented imaginably or propositionally. When we use landmark, road, and survey knowledge, we sometimes use rules of thumb that influence our estimation of distance. These rules of thumb are cognitive strategies termed heuristics. Thus, angles, lines, and shapes are represented as more like pure abstract, geometric forms than they really are. And here are some examples. First is the right angle bias. People tend to think of intersections as forming 90-degree angles more often than they intersections really do. Second is the symmetry heuristic. People tend to think of shapes as being more symmetrical than they really are. And lastly, the rotation heuristic. When representing figures and boundaries that are slightly slanted, people tend to distort the images as being either more vertical or more horizontal than they really are. K themes. The first one is the structure versus processes. The debate regarding whether images are phenomenal or a phenomenal hint hints upon what kinds of mental structures are used to process stimuli. Second is the validity of causal inference versus ecological validity. Suppose you wish to hire air traffic controllers. And then lastly, the biological and behavioral methods. The researchers investigated how people mentally manipulate various kinds of images. As time went by, the team started using biological techniques such as fMRI to supplement their behavioral studies. And lastly, the principles of visual imagery and their findings. So the first principle is our mental transformations of images in our mental movements across images corresponds to similar transformation of in movements across physical objects and percepts. And their study findings, mental rotations generally conform to the same laws of motion and space that are observed in physical percepts, even showing performance dissements and associated with degraded stimuli. However, it appears that for some mental images, mental rotations of imagined objects do not fully and accurately represent the physical rotation of perceived objects. The second one is the spatial relations among elements of a visual image are analogous to those relations in actual physical space. It appears that cognitive manipulations of mental images are analogous to manipulations of percepts in studies involving image size. As a visual perception, there are limits to the resolution of the feature details of an image, as well as limits to the size of the image space that can be observed at any one time. To observe greater detail of individual objects or parts of object, a smaller size or number of objects or parts of objects may be observed and vice versa. The third one is the mental images can be used to generate information that was not explicitly stored during encoding. Under study findings, after participants have been asked to form a mental image, they can answer some questions that require them to infer information based on the image which was not specifically encoded at the time that created the image. And the fourth one is the construction of mental images is analogous to the construction of visually perceptible figures. Under study findings, that lifelong blind people suggest that mental imagery in the form of spatial arrangements may be constructed from haptic rather than visual information. And lastly, the visual imagery is functionally equivalent visual perception in terms of the processes of the visual system used for each. Under study findings that it appears that some of the same regions of the brain that are involved in manipulating visual percepts may be involved in manipulating mental imagery. But it also appears that spatial and visual imagery may be represented differently in the brain.